Welcome dear students. So before starting this question, let me tell you that I have made a very similar video on string impulse and the trajectory of the particle, which I have already posted in my channel, and the link of the video I am sharing in this description. So I would suggest you that you watch that video first so that you can get a better clarity of the impulse and the string motion, and then you solve this question. Then I think it will be very easy. So let us see what this question says. The question says that there is a light inaccessible thread of length L and it wears a massive bead. This red one is the bead, and its one end P is fixed. This is the end. Let us call this end P. It is fixed. And the other end is tied to a light ring. This is the light ring, which can freely slide on a horizontal smooth rod. It can freely slide on this horizontal smooth rod. Initially, the bead is held such that the thread is slightly stretched and the thread section between bead and P is horizontal. So this is horizontal and this is also horizontal, and this whole assembly lies in a vertical plane, so that acceleration due to gravity is g downwards. Okay, so now the question is that bead is given a sudden velocity such that the thread remains stretched always. Find the trajectory of the bead and the inclination angle of bead velocity just after the bead is projected. Now tell me one thing, if we give the jerk to the bead in this coordinates, I mean something like this or this in this direction, will the string remain tight? No, it will become loose. It will become something like this. Here bead and this will be something like this. Okay, that means the projection cannot be in this quadrant. The projection should be in this quadrant, isn't it? So as to string remain the tight. Now let us say just after the impulse is given to the bead, the trajectory follows something like this. Okay, so you have to find the trajectory of, I mean the equation of trajectory of the bead, and second is just after the jerk is given, let us say this is the velocity, so you have to find the inclination angle of this bead with the horizontal. So these two things you have to find, the trajectory and the inclination angle alpha. Let us see how to approach this question. Suppose this is the initial situation. Okay, and now if we give the jerk to the bead, let us say it proceeds something along this track. Okay, and at some instant of time situation is like this. Now what do you think, can this string remain inclined like this? Let us see yes or no. Suppose let us say it is inclined with this vertical at some angle theta. Now already it is given in the question that the string is always stretched. That means there is some tension in this string, and that means if you divide this tension in components, then this ring will be feeling a force t sine theta in this direction and t cos theta in vertical direction, isn't it? So this t cos theta, this will be cancelled by the normal reaction given by this rod, isn't it? This rod, it will give a normal reaction, it will cancel. But what about this t sine theta? This t sine theta will tend to accelerate the ring, and what will be the equation? T sine theta equals to ma, isn't it? A is the acceleration in the left direction. Now here you see m is given to be 0 because ring is light, it is weightless, so m is 0. That means RHS of this equation, this is 0. So if RHS is 0, so LHS has to be 0. T can't be 0 because it is given that there should be tension in the string. That means sine theta should be 0. Sine theta 0 means theta should always be 0. Very important point here. It is happening because of the weightlessness of the ring. That means the situation can't be like this in an inclined mode. Situation should be like this. Okay, the string can be vertical only. That means you see, as the bead starts moving, it immediately pulls the ring along with it, so that ring remains vertically below the bead only. This will be the situation always. Now it has become a very easy problem. Let us say how. Suppose now this we take as the x-axis, okay, and this we take, this one is the x-axis, and this we take as a y-axis, and this point is what? This point is fixed, so let this point be P as given. Now let this height, it is fixed, let this height be h. That means what? What are the coordinates of P? This is origin O 0 0. That means coordinates of P is what? X equal to 0 and Y equal to H. And let us take the coordinate of bead B as X and Y. This is what you have to find, the trajectory. And the initial coordinates, let the initial be positioned over here. What will be the initial coordinate? Whole string length is L and this is H. That means what will be this one? This one will be L minus H, isn't it? So what is the x coordinate of A? It is simply L minus H, and y coordinate of A is what? Simple H. This is the initial point coordinate. Now you see, and let this vertical point, this ring position be marked as n. So length of the string will be what? PB plus MB. PB will be what? Simple, you take Pythagoras theorem, you apply, and you simply put it that what? X square plus y minus H square, isn't it? Y minus H square. This is this length, and what is this length? This length is simply y because it is vertical. So this plus y is equal to length. So write it over here. We can write what? X square plus y minus H square plus L plus y. This plus y is what? This is the total string length. Now what you do? Take y this side and simply square both sides. What you get? You get x square is equal to 2y h minus L plus L square minus h square. L square minus h square. If you cancel the y square and all those terms, that means you see, if you refine it further, you get y is equal to what? Y is equal to minus x square upon twice of L minus h plus L square minus h square upon L square minus h square upon twice of L minus h. So can you, and if you further solve it, then it is simply L plus h upon 2. So that means this is the equation of what? Parabola. Clearly you see, it is a parabola and oriented downwards. It is a parabola. So first part you got that it is a parabola, something like this. If you say x is here, y is here, then the parabola goes like this. Okay, this is the equation of the parabola. Now what second part, what is the question? Second part says that the velocity inclination is what? I mean this angle it is asking about. So as the particle bead is moving along the trajectory, that means at any instant of time the direction of velocity of bead will be in the tangential direction. So this v is directed tangentially to the trajectory at this point A. So what we have to do? We have to simply find slope, I mean dy by dx at A, isn't it? This we have to find, and this will give the slope of velocity, because this will be the slope of tangent and velocity is along the tangent only. So this is the slope of velocity. So now it is very easy. Simply differentiate this one. What you get? You get dy by dx is equal to what? Minus of x upon L minus h. Now x coordinate of A, in the point at A is what? X coordinate of A here is what? Simple L minus h. So put it over here and you get what? It is nothing but minus A. That means slope of velocity is minus 1. So what can we say about alpha? That means alpha is nothing but 45 degree. So that is the answer. So I hope the concept is clear, and the whole crux lies in the issue that ring is weightless. So if there are any questions, any queries, any suggestions, then please mention in the comments and I'll be happy to respond. Thank you.